That's the name of the publisher, .com, and / the name of the author, Carpinelli. That gives you apparently I'm not getting where I want to go. www.addisonwesleynorman.com /Carpinelli. Oh, there you go. Okay, that gets you that site. Under here you have student resources, and under student resources you have simulators. On the simulators, there are various simulators dealing with, from the textbook. The one that you want is Relatively Simple Computer. By the way, there's kind of, I've gotten mixed up here between these two names, Relatively Simple Computer, Relatively Simple CPU. It's Relatively Simple Computer. Run the simulator. It's a Java applet. If you're running it on your home computer, you may actually have to activate Java applets. But on this system here, hopefully they're already activated. So this comes up with a simulator. The other thing that you're going to need is some kind of text editor. So let's use Notepad++. I was going to write this from scratch, so let me wait this out. Okay, I'm going to write a very simple program. It's going to read in a variable x, input the variable x, and then output it. Okay, so here we go. First thing I'm going to do is declare my variable x. All right. Now, so I have, remember I normally split my memory up into two sections, a data segment, which starts at address 0, and my code segment starts usually at what address? 20. Okay. So I'm putting this stuff down at address 0. I'm declaring a address x : this is a label, symbolic address. It's actually going to be the address 0. The directive, you can either use db or dw. db is a little tighter. It stands for data byte, so it's going to reserve a byte. Remember, dw also works. dw means data word. That'll actually set aside 2 bytes. You don't need 2 bytes. This machine has a 1-byte word. I've declared 1 byte, and it's going to start out with a 0 in it. Any questions on that? Now I'll start my code. So I'll put a comment down there. So here's the sequence for inputting x. Right. First go to the I/O port, bring the contents of the I/O port into the AC, then take the contents of the AC and store them into x. That's the input. The next thing I'm going to do is increment x. Bring x into the accumulator so I can work with it. Increment the accumulator. And store the result back out to x. Next thing I'm going to do is output the result. Bring x into the accumulator. And then send it off to the I/O port. And that's the end of my program. Any questions on that little tiny program? All right, now, if you were working with this and you really wanted to, turn it in, you'd probably then, right now, save it. You use whatever features you need to use on the editor. Okay, but then the question is, how do you run it? Well, the first thing you do is you take all this text here, copy it out of your editor, and paste it into the simulator. So I'll do a copy here. I'll do it so you can see it. Copy, right? And I go over to the simulator. This big text box here is where you put your programs in. I'm going to do a Control V, which is for paste, and it shows up in the text box. Okay. Now, then I have to run the assembler on it. That's this assemble here. And if all goes well, it says assembly successful. If not, for instance, you make a mistake here. I think that's a mistake. And you do an assembly. You get a line number and it tells you that there's an error on that line. Assembly language is so simple that typically you can figure out from just the fact knowing what the line number is, what the assembler error is. Okay, and then you go in and of course you fix it. You could fix it here, but remember this is not the permanent record of your program. This is your permanent record, so you probably go back over here, fix it, and then do another paste. But as you know, when I did this mistake, I actually only changed the stuff in the text box here, so I'm going to just get rid of this stuff. And I'll reassemble it just so I have a nice, successful, clean copy. All right, and now it's ready to go and I can run it. To do that, you hit View System, and it brings up a picture of the system. Over here you see the CPU. Here's the memory unit over here. This is the I/O port over here. It currently contains 0 in it. When I run this program, remember I have to input something. I'll have to put something into the I/O port. Now, before you run this, system is set up to do animation. It will slowly show you step by step what's going on. Most of the time you're not interested in that. You want this thing to execute fairly fast. You don't want to sit there for 5 minutes watching a calculation like this. So you go up under View, and it says Animation, it's checked. You would uncheck that. Now it's not going to do animation. It'll run through the instructions as fast as it can. Okay. All right, so now you're ready to run the program. Under the Run menu, you have the options here. Start New Stimulation is typically where you start. However, I'll mention one thing here, that if you're going to have input, you should put it into the I/O port first. So under the Edit menu, it says Edit I/O port. Click that. It comes up with a little text box which allows you to input the value into the I/O port. I'm going to input a value of 5. I don't have to type it in binary. I can type it in decimal. Press OK. And you can see the I/O port is actually now changed to 101, which is a value of 5. Okay. So now I'm all set up for the run. And I'll go back to Run, Start New Simulation. Now this is important. It says Start Address. Why is this important? What if I don't put a start address in there? Where do you suppose it's going to start executing? What address? 0. And what's that 0? X. It's not code, right? It's going to try to execute stuff that's in your data as if it were instructions. It has absolutely no idea when it looks at machine code whether what it's looking at is an instruction or a piece of data. You have to tell it, no, skip that section, start at the code segment. Okay? And the code segment starts where? 20. So here I type in 20. That's where it's going to start executing my program the way that I set them up. I press OK and it's going to start executing the program. It'll execute it all the way to the end. If this executes correctly, what should we expect to happen here? This should change to what? 6. Okay, let's see what happens. All right, so it executed through the program, and of course that changed to 6. Any questions on that? Now, on occasion, you may need to debug your program. one of the useful features in assembly language for debugging a program is being able to step through it. Usually you can figure out just by stepping through it what's wrong with it. Usually don't even have to look at what the variables are. If it's doing the right procedure, typically you'll be able to tell what's going on. So what I'm going to do now is I'm not going to bother changing this from 6. I'm going to run it with 6. It should end up at 7 again. Okay? But this time, instead of doing a start simulation, I'm actually going to step through it. Now, if you're going to step through it, you have to kind of manually set it up. You can't use start new simulation because you saw what happens there. It just takes off and goes. Okay? Instead, you go over here, you set up your I/O port. As I said, that's already set up. Then you set your program counter. All right, manually set your program counter to the beginning of your program, which of course is 20. Now, you can verify that that happened. It shows the contents of all the registers on the machine up here. Here's the program counter. If you look at this, this is a binary 16 up here. This is a binary 4. 4 plus 16 is 20. So the program counter does in fact have 20 in it. Now, what I'm going to do, instead of run the simulation, I'm going to actually do some steps. Step through instruction is what I want. That's Control I. I'm not going to bother using, that menu. I'm going to use the control keys here. So I'm going to press Control I. And actually nothing's, has it happened? Nothing's happened so far. It's just started the simulation. It's currently at the first instruction. Now it's moved on to the second instruction. So it's currently has executed load ACFFF. So what should now be sitting in the AC is 6. There's 6. Okay. The next instruction, when I press Control I again, would be stored into X. We won't see any changes to the registers when we do that. That changes memory. Okay, but I'll push Control I. That's been done. Okay. Then the next instruction would be load X. Again, the 6 is going to get loaded back in. Control I. There's Control I pressed again. And then increment. This time when I press Control I, the AC should change to 7. Okay, change to 7, right up here. And now I'm doing the store instruction. That should have no effect on the registers. That just stores it out to memory. Control I. So you can see how you can step through this thing, one instruction after another. Then, of course, you're going to load it again. And the next time I press it, it should store that value, that 7, into the I/O port down here. Okay, you can see the 7 got stored in the I/O port, and that's the end of the program. You'd stop stepping there because you're done. Right? So that's how you step through. Any questions on that? When you do the problems on your homework, turn in a listing of your program. So you just do from this file here, you just do a print. And then go over to the this machine after you've run the program and take a snapshot of this simulator here and turn that in as the results of your test run. Okay, any questions on that? All right, so that's the demo. That should allow you to finish. I think I still had to talk a little about problem 1.